So yes, thank you everyone for joining. This presentation is a glimpse, is a summary on data manipulation using NumPy and Pandas in Python, and also algorithms which are decision trees and random forests. So this deck is basically a culmination of around 2 years of headbanging of experience as a data scientist working with Kotak Mahindra Bank and UBS, wherein I'm working on the latest machine learning algorithms and robotic process automation tools, Python and automation anywhere to get to manipulate the data and make predictive. So since we have a multivariate audience, we have people who are complete novice and we have people who are highly experienced. I have divided the slides into green and blue colors. Green slides, everyone, please don't skip them. Whereas blue slides are only for the people who are a bit curious and wants to go into more technicalities of the topic. Talking about artificial intelligence is the science of today. It is everywhere around it. It is from a recommendation system in Amazon to the personalization software on your mobile, from tracking, from self-driving cars to understanding patterns in digits. Artificial intelligence is everywhere, and machine learning is a subdomain of artificial intelligence, which machine learning is basically a subdomain of artificial intelligence. It can be termed as a narrow AI, in which we artificial intelligence only for a particular topic of use. So the systems that are trained to do one or more defined things better than humans are basically called machine learning, and the data, all these things, the recognition is done basis of systems that are created by the codes written by humans to convert it into a self-learning system. The popular use cases of artificial intelligence, these are all mentioned, and we all are very much aware about it, from object recognition to speech recognition, from natural language processing to natural language generation, sentiment analysis, or creative things like building up a piece of art, or predictive, wherein we can predict will be a long-term customer if he is liable to take another loan, or if there are high chances for him to leave our service. Those kind of predictions can also be made using artificial intelligence. As I told you, machine learning is an approach to achieve artificial intelligence that can learn from experience and find patterns in a set of data. The beauty of ML is that it learns from itself, from the data passed to it. Machine learning is basically divided into supervised learning as well as unsupervised learning. A supervised learning approach is an approach wherein the training data is labeled. So we have a target variable and we are training the machine to identify the target variable through making rules within the data set in the algorithms that find patterns in the data set by giving weights to each and every variable. Supervised machine learning algorithm would be something like a decision tree or a logistic regression or a simple or a multivariate regression model, whereas unsupervised learning is a learning in which we are not giving machine a labeled data set. We are basically giving it set, and the machine has to find out in how many clusters, what kind of clusters can the data be divided into without any target variable. So the complete data has to be plotted in the hyperspace and be under and try to make sense on how the data points are which together which make a cluster, and what are the data points are different from these data points. So as you can see in this image, the supervised learning algorithm basically tries to classify data or two classes of data within a data set by linearly separating them in a hyperplane. Whereas in an unsupervised learning, the data set is not being, there's no boundary that is being made in the data. we are not working on creating a boundary, but we are working on separating the classes on basis of its own attributes. An unsupervised learning algorithm would be a k-means algorithm or a hierarchical unsupervised learning algorithm. So since this is just a half an hour demo, I would quickly move you into data manipulation using Python, wherein I have written some sample codes on NumPy and Pandas to get you started. First of all, some of you might be thinking why we are really using Python for the data manipulation purpose. There are various languages market, including R, SAS, Python, and many others for different purposes. But Python has proven to be the most reliable of all those languages in the long term. Even the Facebook core code is written in Python, and the reason for that is that Python is highly scalable and it is very simple to understand. It is a interpreted language, which means that the code that we write on the computer, basically, which is equivalent to simple English, is then converted into machine level code and compiled, and the results come back. So let me move into.
Shubhankar, I have one question.
Sure.
Now, if I'm coming from a non-technical background, I am from a mechanical background, how comfortable would
I,
Python be for me to learn and get into the data science portfolio?
sure. Since you come from a non-technical background, data science requires coding, but to a very minimal level, in which Python is the easiest to learn of all the three languages. And believe me, with a few days of practice, within a weeks of practice on data manipulation, with the codes that I share with you, you will be very much comfortable using it. Regarding the machine learning aspect of using in Python, the codes that are written in scikit-learn library for machine learning are maximum 3 or 4 lines of code. The only thing that you have to edit in those codes is the hyperparameters. So the hyperparameters comes from a statistical knowledge of the model, which is no coding. So I would say there's very minimal coding, and the coding that there is can be learned in a few days. So it is easy for you.
Thank
Sure. And also you can see in the following code that I'm presenting, which is mostly on sorting and merging data frames, you will see that the codes are you will can generate an intuition of the code, because the codes are relatively easy to understand. And let's start with it, and you can ask me further questions too. So we will be going to learn to handle data sets, creating and reading from external files. But first of all, I will give you an introduction to NumPy. So NumPy library is one of the few Python, and other popular libraries are Pandas, Matplotlib, Cbond, Math package, etc. So this is basically a library is a collection of functions which are predefined and already stored somewhere in the Python code, so that you can access them, and it makes your coding easier, because the basics of the code are already written in a function. So understanding what are the data types in Python. The basic data types in Python are list, tuple, and dictionary. So a list is a list is a kind of array in which you can store multiple entities, including a number or a string or a decimal, or even a sentence. So let's try that out. So if I want to describe a list, I would be starting with the square brackets. So these basically signify list, in which I can put in multiple values, and this list will print that for me. I can utilize it to enter a string, and that is also formatted in a list. So A tuple on the other side is similar to a list, but the only property that is different from a list is that it is immutable. So once you have made a tuple, you cannot really uh, change it. The values in it cannot be edited. A tuple is defined by round brackets. So if I want to append a value in a list, which is possible, but it is not possible in a tuple. So we'll come back to tuples and lists in the following code, but before that, I'll be showing you basics on NumPy. So we are creating an array, a two-dimensional array, and we want to understand what are the size and the basic attributes and how we can manipulate data within the array. So let's create an NP array. We can create it by using a function called np.array. Yeah, before that, I would also like to tell you about the aliases. So we have imported this package called NumPy as NP. So this as NP means that this is alias, which means that instead of typing NumPy everywhere, I can instead just type NP and it will work the same. It will signify the same thing. So it is not defined because I've signified NumPy as NP. So yes. So aliases are used for most of the codes, most of the library. Um, and the common alias for NumPy is NP, whereas for Pandas it is PD. So we have created a two-dimensional array which is 4 into 3 structure, and we want to understand what is the shape from the computer. And yes, it is 4 into 3. We're talking about indexing. So indexing is basically extracting a value from either a data or an array. And a special thing about Python indexing is that the dimension that we need to pass starts from 0. So I'll give you an example. So we want to access, suppose, 20. So for accessing 20, I must go to 0th row, and I must go to first column. So the row starts from 0, the indexing starts from 0, 1, 2, 3, whereas the column indexing starts from 0, 1, and 2. So if I want to access 20, the index would be 0, comma 1. Yes. Um, So this is one important thing to note in Python because this is different from R. In R, the indexing starts from 1, whereas in Python, the indexing starts from 0. So this is one important thing to always keep in mind while indexing objects. Also, indexing can work for lists also because just in 2 dimensions. So if I want the complete first column, then this could be the code. We can index in such a manner that we are selecting all the the row, whereas we are selecting just the first column. So I can also select the 0th column, which is this one. If I want to select only the second row of the data set, which is minus 13, 4.5, 26, then I would 1, comma, colon. Colon means all. So select all in the first row. Yes. If I want to access a single the same row, we can also access it instead of saying colon, because if I say B1, it automatically means that I'm referring to the row. Whereas if I just do a comma, then it will understand that I'm accessing the first column. So another trick to index the dataset is that I can give 2 list structure within it. So which basically will mean that I am accessing सबसे पहले first of all, be 0 comma 1, then 1 comma 2, and then 1 comma 1. So it is picking up first element from the first list, matching it up against the first element of the second list, and the second element in the first list, and the second element in the second list, and so on. So it will give me three results, which will be 0, 1, 1, 2, and 1, 1. So as you can see, 0, 1 is 20, 1, 1. So 1 will be this, and 1 will be 4.5, and 1, 2, the last element. 4.5 is the last element, 1, 1, whereas 1, 2 is the first element, and the second entity here is 26. Moving forward, we can also change these quantities. We can also uh, manipulate the data to put in values at the same places. So yes, please.
So more like we are talking about the matrix distribution here, right?
Not able
Have
to hear you, Gautam, please.
I said more like you're saying that matrix distribution. So we are trying to find out the rows and columns, the values, right?
Right.
Yeah, go ahead.
Yeah. So we are basically doing the matrix manipulation because it will eventually updating list and other columns in the data frame. We are trying to understand how we can access an element within a matrix. It might be a matrix of an array, where it might be a matrix of a data set, or it might be a matrix of an list under a list. So in this particular code, I want to signify that we can replace the data by simply equating them to another element. So as you can see here, we had the initial data set which we printed by using print b, and we are changing three entities here, which is first is 0, 1. So 0, 1 is as we had discussed, 0 is this row, and this column, so 20. We are replacing it with minus 10. So yes, it is replaced with minus 10. And similarly for the other two entities, such that we have minus 20 and minus 30 here. If you want to get only the values from B which are greater than 0, this would be the code in which I am indexing within B to select values which are greater than 0. Another thing to note about Jupyter is that you can either print an element, or the last element within a block of code gets printed by itself. So even if I don't write a print here, it will be printed. But if I don't write a print statement here, this one will not get printed. I print statement here because only the last elements get printed by itself. Moving forward, I wanted to give you a glimpse on the Max package. So we can import Max as M, and if we want to change the value of any element in D with the absolute value of it, we can do that as well by using np.absolute function. As you can see, this particular row of code, we had changed this to minus 13, minus 30, and minus 20, and now we want to change this complete row of this complete row into positive, into absolute values of these terms. So to convert them into positive integers, we just have to mention np.absolute, and we have it. We can also do a square root. We can do sum, and let me take you through the access. So access 0 basically corresponds to the elements across the list, whereas access 1 corresponds to within the list elements. So what I mean to say is that we have I have passed a sum on B with the x is 0. So x is 0 means the element within a column, whereas x is equal to 1 will mean the sum within the row. So x is equal to x is 1 basically represents the row, whereas x is 0 represents the column. So it would be different if you want to do summation of a row or a column. It comes handy both ways. Another functionality of NumPy is creating a list of integers or creating a random list of integers. So um, if you want to create a list of integers starting from 2 to 8 with a gap of 1, this would be the code and the function would be arange. So if you want to create it till 100, and if you want to give a gap of suppose 5 between each element, then we can do that as well. So the code starts with creating a number from 2, adds up 5, another element 7, and goes up till the number is less than or equivalent to 100. So these are some ways to create random lists. If you don't want the spacing of 1 between range of the variables, the range of the array, then we can use the Linespace function in which we have to mention the stop and the start and the stop and number of elements that we want in the array, and it will produce them in the decimal fashion. It is not required that it will really. And if you want to generate random integers from the NumPy functions, which is also possible using the random function, which is mostly required while we are or some sort of dummy analysis. So I have created a array of 2 into 3 matrix, and I wanted elements only between 1 and 10. So here it is. Now moving forward, we will be working on pandas. I have given you a small summary on NumPy, how NumPy works. I would be interested to tell you how we can manipulate data using pandas. So we are creating a data frame in which the three columns would be age, city, and default. And we are using the same functionality of NumPy to create um, random integers between 16 and 18. The number of elements will be 20. I'm also using random choice element, which will random one of the entities out of Mumbai, Delhi, Chennai, or Kolkata for 20 elements. And same goes for the default column. We are randomly choosing a number between 0 and 1 20 times. So let me just run this and let me create my dataset. So I'm creating my dataset by using the zip and the list function. The zip function basically does the basically matches index, zeroth index of all the three elements with each other so that they are aligned, and then it will create them into a list. So I'll just show you the output of what does the function really does, because it is very interesting to see this function. This function is very highly useful. So we cannot really access a zip. We have to access them within a list, and so zip function basically converted, you use the first element of age, the first element of city, and the first element of default, and put them against each other in the first element of the list that we are further creating. Since we want to make a dummy data set, this function will help us. This function also helps in the for loop condition a lot. So when we want to supposedly when we want to pass two variables, two columns in a for loop statement together, and we want them to pass at the same index every time, the zip function comes handy. This might sound a little fancy for those who are beginners, but we will be seeing for the use case of the zip function. use it in the for loop. So I'm using the Pandas functionality of creating a data frame, wherein we use the function data frame and passing the data, my data, and telling it the column name. So mind that we are just telling it the column names here by um, these are just the names, and these do not really signify that we are creating, because even if I give it a name of age one, it is not yet referring to the original data that I'm gonna give it. So just creating a structure for a data frame. It doesn't really contain anything as of now. This code is pre-run, so it will contain because I have already run it before. Yes. So I'm creating a data frame now by using the dictionary. So we talked about lists and we talked about tuples, but we did not talk about dictionary. So dictionary is another kind of data frame in Python. It is very interesting to know about dictionary. We can go about it in detail while we study the data structures. We have the data ready with us, which looks like this. I will be importing a CSV file into the Jupyter notebook so that I can do some data manipulations on the CSV file. So just to let you know about reading the files, we can read string files, CSV files, Excel files. We can also read from databases very easily in Python, and there are functionalities for all kinds of sources of data. For we will working on a loans data file, which is available in this folder. So I just need to specify the path of of my CSV file. The R at the beginning means it is a raw string. So the real code for reading the file is pd.read CSV. So it is passing file. File is the variable name that we have created here, which contains the raw string for this particular CSV file. So let's read it. Okay, and let's see how it looks. Yes, so we have read the file, and the file looks quite clean. I want to know how many columns and how many are present in this particular CSV file. So I'll use the dot shape function, which will tell me that the file has 2500 rows and 15 columns. It is difficult for me to see the complete all the columns in the data set. I just want to know the column names. I can use a function called dot columns, which will give me a list of all the functions that are in the data set. If I just want to know the types of columns that are there, we can also do that using the dot dtypes function, which basically tells you the data types.
So, Bhaskar, I just wanted to understand if I
Sure.
jump into this function we have the different functions or syntax with their what exactly it does. So it's more like I'm talking about a dictionary or an encyclopedia to have syntax and its functions. So has it been taken in during the training, or it's like on when we are doing this kind of program that is done the students are doing?
So your voice is breaking a lot, and I'm not being able to make much sense out of what you're saying.
Okay, so what I'm
Uh,
saying is now see we are talking about different functions in the entire the whole thing that we are learning right now with respect to the matrix element, the data, and simplifying the data into a structured format. Now, do we have something which we are going to learn in advance before going into this? And you help me out
okay.
understanding that these are the syntax, these are the functions which are used for this purpose. Is that something is going to be a part of our learning curve, or it's going to be something that we are learning on hand on this platform?
Yes, so basically, so this is a demonstration. I'm taking you to NumPy. There are people who already have the basic knowledge of what the data structures are, and people who have knowledge about how the data structures work. But this is an important part of manipulating data using Python. The thing is that while you are into a real job as a data scientist, most of your time goes into cleaning the data and merging the data to create the data set. And this is the job that requires real skill. You wish to be able to understand what are the data types and how you can really manipulate the data to create new columns, because you might need to create new features out of the existing features to feed into a model. So this will be a part of your learning, and it will be a core part of the learning. I hope I answered your question right, because there was a little bit of disturbance and I
Yeah, I got my answer.
thank you very much. So yes, moving forward, we have a lot of functions that we can go through in Pandas, but the most important functions have been mentioned here, and I will just skim you through these. So one is the head function, in which if you want to just read the top five lines of the data set, we can use the head function, and we can also see the top 10 rows by mentioning that. We can also see the last few bits of the data set by using the tail function, which will give you the last 10 rows in the data set. So starting from 2490 to 2499. And the interesting fact, note that the 2499, the main reason for that is that the index starts from 0 and there are 2500 values. So the index will stop at 2499 here. I can just do a control and backslash to make it into convert into comment and then run it so that the output fades away. We have already been gone through the columns, the details, and the shapes of the data. Now we should talk about how to index a data frame, wherein we are using the same trick that we utilized in arrays, but in a bit more advanced format. So my data frame looks like this. Suppose I want to access the amount and I want to access 20,000 here. I will most probably be using LOC, which is index location, and I will mention that I want the 0th row and the first column, which will give me 20,000. If I want to select, let me just open up the. If I want to access rows from 0 to 2, and I want to access from 0 to 2, which is ID amount, requested amount funded by investors, I would mostly be doing something like 0 to 3 and 0 to 3. So you might have noticed one thing, that I wanted the second, I wanted till the second column, but I mentioned 3 here. I did not mention 2. I mentioned 3. And here also for accessing the columns, I'm mentioning 3 instead of 2, because the Python indexing works in such a way that this index starts from 0. If you're mentioning the start and the end location, the start location will be inclusive, whereas the end location will be exclusive. So it will go till 3. It will not be taking 3 as a part of the indexing. It will go just till 3. So this is the second most important concept in indexing, and it is one of the core values of Python, because uh, this is very necessary to know, otherwise many mistakes can be done while manipulating data. So now I think we'll be able to make sense out of what this code is doing. It is basically selecting the rows, because it is before the comma, and it is basically selecting the rows from the third row to the sixth row, and it is selecting the columns from the first index column, which is the second column basically, till the fourth index column. So let's see how the output looks like. So we have the third to seventh row, third to sixth row, and we have columns starting from the first column to the fourth index column. So we have the first column are requested amount funded by investors, interest rate, loan length. But we have not taken this particular column, which is index 5, because we are indexing till 5 and we will not be taking that one, we'll taking till 4. Hope that makes sense. And moving forward, we are indexing another one here from the second row to or till the fourth row, so including the second and the third row, and including the first and the second column. So we have, you might have mentioned, you might have noticed that this one here is showing you index 5 and 6, wherein we selected just 2 and 4. Is that we have already created a subset of LD of this particular data frame. So we have saved this particular data frame in LD1, and this LD1 we are accessing second and fourth from LD1, which means that we are accessing 0, 1, 2, second, and third. These two rows from this data columns 1 and 3, which means this particular column, but not this column. So we are basically selecting this data out of this, sorry, these four entities, 6,000, 15.31, 10,000, and 7.90. If it was the old, our old original column, then we would have got the same indexes, 2 and 3, with the same, the original subset of the original data frame. Okay. Now we'll be working on utilizing how we can create conditions, how we can subset data on basis of certain conditions. So if I want to select the data only where a variable called home ownership has the value mortgage, and the column where monthly income has only the values greater, the code for that will be this. So we are basically telling the system that please go into LD and select the data set in which the home ownership is equal to mortgage and the monthly income is greater than 5,000. Let's try to do that. And
So would it mean that the homeowners would be basically represented by the mortgage amount?
sorry.
I said we are replacing home ownership to mortgage, and monthly income should be greater than 5,000. Now, are we uh,
Right.
are we shifting this homeowners to the mortgage values and filtering the
Sorry,
information?
I could not get the last read.
I'm saying that are we replacing the homeowners with the mortgage value, and monthly income should be filtered and should be above 5,000.
Okay. Uh, yes. So what you're basically asking me is what these operator means. So this basically is an equal to operator. Is an operator here. This does not equate it to mortgage. If I had mentioned equal to mortgage, then so for example, answering your question, we are not basically changing home ownership to mortgage. Home ownership is a variable because it comes within the single square brackets in this data frame. We are comparing the values of home ownership, and if the values comes equal to mortgage, then only we are selecting it. So another thing that I can be doing here is that, so I can create another column called home, which is equal to mortgage. Equal to won't work here. I will have to put a single equal to if I want to equate something to a new value. And I will show you LD now. So LD is this data frame. I have created another column called home in which all the values must be mortgage. So as you can see, this last column is home that we just created, and all the values here are mortgage. So there's a difference between the equal to operator and the comparison operator. We will be having separate class for it to learn about all the operators that are used in programming languages. Um, so we have the greater have the equal operator, we have the less than or equal to, greater than or equal to, and we also have not equal to operator, which basically looks like something like this, exclamation mark followed by an equal to, and that makes it a non-equal to operator, and it can be utilized many places. So if I don't want home ownership equal to mortgage, I want all the values that are except mortgage, I can also do that. So uh, run this code, and yes, we have some. Let me just select the loan purpose, which are into debt consolidation. So yeah, this will be a good example. So I'm selecting the variable in loan purpose, and where is debt consolidation. Also mind that Python is a case-sensitive language. So if I make this D as a capital D, it won't really work because it is a case-sensitive language, and the things that are capital must remain in capital, um, even for the function and all the libraries. So I'm selecting loan purpose in debt consolidation only. The credit card field should, or the card field should really go away from this loan purpose column, and the monthly income is greater than 5,000. So, so yes, we have all the loan purpose in debt consolidation. If we want, if we use a null operator here, we will have all the fields debt consolidation. We can also enter multiple conditions here using the AND operator, which is another operator used in Python or the programming languages. And so I can also select a state. So let's try this. I'm writing down the state in the small caps, whereas really the state is in normalized caps. The first letter is big and the other letters is low, small. So it will throw me an error. The error would be that recognize state here. So let me try if I give the original variable name to it. Will it work? Yes, it will work. So we have given another condition in which LA should be all the fields should be manipulated on basis of these three conditions. So yes, that's about condition. Apart from conditions, we can columns that we really want to see in the data frame, because it is not important that we always want to see all the columns in this data frame. So that can also be done by putting in a list of the variables that you want. So suppose I just want to see the ID column and the state column in the scenarios where the is not debt consolidation, the monthly income is greater than 5,000, and the state is LA. So did I do an LOC? Okay. So the only thing is missing here is the LOC. I did not tell it to locate. So important here. So yes. So we have got the data set. We have got the column names, ID, and state for the condition that we have entered. Moving forward, we are creating another data frame here, which is which contains a random choice of number from these few values for 50 times. So that will be the column age. We are creating a variable called pico, which will be a string basically. So since another thing to notice here is that a number that we signify normally without any without any quotes is an integer, whereas something that we input within single or double quotes is a string. You put it in single quotes or double quotes, it really doesn't matter in Python 3.0. Um, so as you can find out here, this 10 bit is a string bit, whereas this 12 bit is an integer bit, and we are choosing one of those for 50 times to generate the age list. We are doing the same for FICO. We are choosing one of Mumbai, Delhi, Chennai, or Kolkata cities for 50 times for city, and we are creating a function called ID, which is creating a list, which is creating an array from 1 to 50. Since we are inputting 50 into it, so it will basically create a array from 0 to 49. That's how Python works. And similarly for other fields, then we are finally creating the data frame using data frame function. And this is a generic script that is used for creating a data frame if you want to create it yourself. Sorry, I not read this code. Okay. Yes. So let's see how my data looks like. Is it the way I really want it to be? Yes, it looks like good. So ID is there from 0 to 49. We have the age, um, and we have balanced children. City FICO rating. Rating is basically either excellent, good, bad, or pathetic. FICO have four entities. City mentioned, children. Yes. So good to go. The one problem here is that I cannot really do any kind of data manipulation on age because age should have been a numeric entity, numeric variable, whereas age has got one or two string variables too. So I will check what are the data in my data. So I have age as object, whereas it should have been an integer. All the other fields look good. I will be creating my age into an integer. So the function for that is pd.toNumeric. Another thing to notice is that Python is quite self-intuitive, and if you want to generate, understand few functions that you want to toggle around the functions what are present, you can just do pd and dot and then hit a tab, and you will get the range. You will get the list of the complete functions that are available within Pandas. So yeah, hope you can find some time to browse through those. Similarly, you can also look out for functions in NumPy using NumPy dot and tab. So here we are with all the functionalities in NumPy. So I've converted my age into numeric. So I have passed the same column, my data age, within this function called to numeric, and I have told it for the errors to coerce, which basically will give me an output something like this. So the missing value has converted into an because I've converted into and it was a few numbers which were there were few strings missing. They have been converted to not NaN, which basically means null values because it could not make sense out of the word missing there. Since we have converted into numeric variable, now we can do certain data manipulations on age also. So I'm creating a new variable called constant variable, constant var, which will have the value of 100 for 50 times in the data set. I'm also creating another variable called balance underscore log, which is basically a log of the column balance. And I'm creating the new column using data manipulation called age children ratio, adding my data of age with my data of children. And by let me see how the results look like. Okay. So yes, I have got the constant underscore var, which is 100 everywhere. Log of balance and age children ratio is basically dividing the age by the number of children, and it is giving me right values. Yes. if I want to calculate the number of nulls that are present in age, we can use dot is null function. So we can specify the column that we want to calculate the null in, and we can use the is dot null function dot sum to calculate the total number of nulls. And if you want to see the presence of null, we can use dot is null function, which shows the index of the places where null is present. So it is present in two places, and the sum is already two. A common thing that is done in machine learning while cleaning variables is outlier detection and also imputing missing values. So there are many missing values in a data frame, which can lead to loss of information and also make you in such scenarios, we have to manipulate the variables. For example, in a diabetes data set, once I was working on a diabetes data set, and I checked out the blood pressure column, and I plotted the range of the blood pressure column, and I got to know that there are many values in the blood pressure which are negative, which is not possible. The practical range of blood pressure is never negative. So figure out how many such cases are there. There were around 30% of cases. Since there were 30% of cases, I could not really rely on this data set for that variable. I had to remove that variable. But if it were fewer cases, suppose 30% is a good threshold. If it is less than 30% in a classification problem, you can always make business sense and all values into the mean values of the remaining entities. So suppose you have missing values at 30% places or 20% places, you can take the mean out of the 80% use cases that are available and plot the mean value in all these 20% cases. So which basically does not change the distribution of your data set, but eventually it will give you the information that it is required. So definitely that is not the business problem, but it is a popular way to deal with missing values. We'll have a separate session on that in which you can talk completely about how to impute missing data. So what I'm doing here is I'm basically locating in my data where the my data age column is null. So is equivalent to simple English, and I'm accessing age column here. So what I would love to do is I would just show you the output of this. So we have got the location 23 and 42 where we have null values in the column age, and we want to replace these two values with the my data age. So the mean of my data age is 25.395, and so we can also calculate the sum if we want, or the mode. The other values. So in few cases, you can also use the mode of the data set because field. So for example, if I have a data set in which I have many missing values, and it is the data set of the person might be having a car or a, but I see that in 80% of the cases it is always car, and the mode is car, so I can also select car for the missing values. Although it's different sense that data will not, that variable will not give much sense to the model. Don't have many classes, it has high chances of correlating positively with the target variable, which is a problem called autocorrelation, and we really don't want autocorrelation in our data set. So coming back to this topic, we can always have another talk on autocorrelation, multicollinearity in a different presentation. I'm replacing these two values, 23 and 42, with the mean age of the remaining columns, the remaining values, which is 25.35. So this code will basically replace the null values with 25.39. I am also creating another. This variable was already created. I don't need this anymore. So let's see how my data looks like. It looks the same. The age values, I guess all the missings are gone. So I'll just check it again. So age is, let me just quickly find the sum of zero. So yes, we are good to go. We don't have any nulls here. Moving forward, I also want to create. I also want to create another variable called rating score. So my data set, my data already has a variable called rating, which is an excellent, good, bad, but variable. A dummy variable is another very important concept while deriving variables. So going forward with a classification problem, mostly in decision trees and random forest, you do not give a continuous variable. A continuous variable is something that has infinite number of classes or very high number of classes. So for example, of numbers between 0 to 100, or a continuous number, for example, the mileage of a bike, or something like the number of cars in a city. It could be any number. It could be a list of any number, and that is mostly a continuous variable. Whereas a class variable is something which has classes. So, for example, this particular data, um, this particular column called rating, it could either be one of good or excellent or bad or worse, but it cannot be a number which ranges from 0 to 100. It cannot be continuous. It is defined. So these are called class variables, and this decision trees we cannot input continuous variables, so we make dummy variables out of continuous variables also by converting the continuous variables into a range. For example, I have a variable which ranges from 0 to 80, or suppose 5 to 80. So I will convert them into brackets of 5 to 10, 10 to 50, and so on till 75 to 80. And then I can also create dummy variables for the same age bucket if that proves to be a very important column in my data set. So I can dummy variables, which is basically separating into a variable into a new variable and giving it a code of 0 or 1, 0 or 1. So that is what we are going to do here, and example in front of us. So I'm using the where functionalities in NumPy, and I'm searching for rating. If the rating is in good or excellent, so NumPy, where my data rating variable is in either good or excellent, then please give the value 1. And if it is not one of good or excellent, give it the value 0. That's variable will do. So let's run that and let's see what I really mean in words. So we have the rating score here. I told you it is excellent or good. We are giving 1. It is not one of good or excellent. Bad is not one of good or excellent. So the rating score is 0. So uh, this is another way of creating variable in Python. You can also filter this data out on basis of rating score, either 1 or 0 if you want just excellent or good. Moving forward, so let me get data frame, and I will quickly wrap this data manipulation bit up because we have dealt with understanding what a list is and how we can manipulate an array, data frame, how we can index the data frame. Now, the next few bits that are required for the short demo are merging the data sets and also grouping by a variable. These are two important things that I would like to show you, and also I would like to give you a simple example of a for loop. So I'm creating another data set here, which will have random integers from 2, 8, and a tuple called 24, 20, comma 4. So let's see how this looks like. So you might be wondering how this A, B, C, and D came as different 4 columns. We are converting a string into a list. So when we convert a string into a list, then it breaks up all the entities of the string in individual letters. So So we are basically creating random integers between 2 and 8 for a matrix of size 20, comma 4. And here is how our data set looks like. Now I would like to show you how to sort the values. So I want to sort the values of A, and let me just delete this in case is equal to true. So I have values starting from A. So A has starts from 2 and it is sorted. If I again data frame, you will see that the sort has gone. It was only limited till I was presenting the data, so it is not permanent. I have not placed it inside. I have not basically, implemented it. Indeed, I have just sorted it for. So when I use this functionality called in case is equal to true, it basically converts DF into a new data frame with this function implemented. So now the original data frame DF will have the values sorted by A, and our data frame will look like this. So this is a new data frame in which the value is already sorted by A. We can also do a descending sorting by using the function hyperparameter called ascending is equal to false. Ascending is equal to true is the default value for it, whereas ascending is equal to false will be descending. So we have also done in place is equal to true, so the data frame will originally convert into the descending values of A, which is we can also sort multiple columns at once. So here and we are passing 2 columns B and C and telling the system to first sort on B as ascending is equal to true and C ascending is equal to false. Let's see how the results comes up. So B is being sorted into ascending, whereas C is sorted into descending. Now we will be talking about merging the data set. So we are creating 2 separate data frames. I'll directly the output of the data frame now. So one is this data frame in which we have 2 columns called letter and number, and then the data frame in which we have 3 columns, letter, number, and animal. And so that's how the data set looks like. If I want to concatenate the data set, which means that I want to combine them vertically, then I would be using the pd.concat function, which basically data frame 2 on x is equal to 0. Since I did not have any animal variable here in the first data frame, they are coming as missing. The missing values are generated. So the only difference in this code is in ignore index bit. So this is a hyperparameter which basically tells you to create a new index. So as you can see, the index for this was a bit disrupted because we have concatenated. It was 0, 1 for the first data set and 0, 1 for. Whereas in the second bit, when I'm ignoring the index is equal to true, it is creating a all new index for the new data frame. So that's the only difference that you will find here. There's another third data set that we are creating, which looks like this. We have the animal and the bird name. And now we want to concatenate these 2 columns, data frame 1 and data frame 3, basis of access 1, which basically concatenates them horizontally instead of vertically. So if the data set have the same number of rows, it doesn't really matter how many columns are there in the data set. If it has same number of rows, then it will join in easily without creating any missing values. So that is a short summary on concatenation. Moving forward, let's talk about joins. So I'm creating two different data frames. One is data frame one, which has a customer IDs and product. So it is a simple data set of 5 rows uh, with customer ID and products. And data frame two has customer ID and state. So we want to merge these two on the basis of customer ID on the first column. So which means that it will be a left join. So I basically want to see that I want to extract the state for the customer IDs available in the data frame 2. So I want to plot UP, UP, and UP against 3, 4, and 5. For this particular purpose, we use a function called pd.merge. So we use pd.merge. I'm specifying that I want it against data frame 1, which should be my left data set. Data frame 2 should be my right data set. And what kind of join do we want? I want an left join. So I'll specify how is equal to left. I now want to tell on I want the join to work on. So on hyperparameter will tell me that I can specify that I want to do on customer ID. Okay, so that is all we need to do a left join with that is equivalent to a pivot table and DataFrame. So yes, since the customer ID 1 and 2 were not available with me in the second data frame, that has not come through. But I had 3, 4, and 5, and I have got extracted the right values against it. So good enough. There could also be a possibility when the column name would not be the same for data frame 1 and data frame 2. In such a scenario, we can tell it that the left on column is customer ID, whereas the right on column could be something else than customer ID. Since in this case it is customer ID, we will take customer ID again, and that results are same. Instead of left join, I can also do other kinds of join. So I can do an inner join, which will basically select only the customer IDs which are present in both the scenarios. The customer ID which are common in data frame 1 and data frame 2 are 3, 4, 5, 6, 7 are not present in the first, present in the second data frame. So we have 3, 4, 5 which we have got in the inner join. If we do an outer join, we'll get all the values, and if we do a right join, then we'll basically be joining on data frame 2, and we will get the values from data frame 1. Um, yeah, so this is about joining the data sets using left join or right join. If you have any questions regarding the same, you can ask me anytime.
No, we are good to go. It was pretty explanatory. So
Thank
I'm
you very
agreeing to
much.
all the part that you have done. So is there anything else? Because it was too much for us to understand, and it was not that difficult that I understood that this components are pretty easily achievable when you do a little bit of practice.
Right. Absolutely. So I'm glad to hear that it was pretty easy for you because I have tried to give my personal best to make it easy. This is mostly an exhaustive list of functions that you might in Python. And with the study of the single notebook, you will be 50% good to go to manipulate any data set. The only two concepts that are very important and are unexplained at the moment are the if-else functionalities and the for loop statement. So these two are another very important concepts. So I would be happy to take you through in them in detail if the session is not going too heavy on you.
No, 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 that's okay. That's okay. If you can just quickly give us this if and for loop, so we can wrap up the entire session after this.
Sure. So let's work with if and for loop, and I'll be creating if and a for statement syntax in front of you live. So let's think about some use case. Let's deal with the same data frame. So let me just take this data frame in a new data set called new df, and I have the new df with me, which looks like this. So I want to loop in all the customer the data frame. I want to loop in through all the customer IDs. So what I will do is I'll use a for loop. So for loop is used when you want to loop through a range of values. So let's try this for item and new df. Correct. Okay. Print item. To see here what is the item that goes on in for item. So if you have studied for loop before in Java or in C, then the for loop used to contain three entities. One was the initial variable, second was the increment variable, and third was the condition. So in this scenario, we basically the system a list of things that you want to pass on, and this particular bit of code is any name you can give. So instead of item, it could be uh, case, or it could be anything else. It does not really matter what it should be named like. But what we are basically doing is we are looping in the variable customer ID one by one. So you have seen all the values of customer ID right now, but the next bit will be to print uh, line along with it. So the sense that I want to make here is that when we are using a for loop, it is first of all printing and then printing the case. So the case here is basically here is the list of customer ID in loop one. So for the first scenario, it will take customer ID 0 and it will print case, then the case value updates itself when the loop gets over, and it again comes back to the starting of the loop. The customer ID gets updated to the second value, which is 4. So case will then contain 4. So that's why 4 is printed. Again, it goes back to is revised with the new customer ID value, which is the next value in the list, which is 5, and so on. So that is how the basic functionality of a for loop works. It um, okay. So we have another variable called I. Let me create another variable called I, and I will increment the value of I with 1. Let me also set up an initial value of I, which is 0. So what I'm doing here is that I'm incrementing the value of I by 1, and then I'm printing I. So the I will have a value of 1 when it's printed first time, and then the loop goes back into the code, which is I is equal to 0. So that is not something that is going to happen. It will not go to back to I is equal to 0. It will remain within the for loop until all the values of new DF customer ID are fulfilled, which are 5 values. So I will create, and I will have the updated value of I by the end of the for loop. So as you can see here, I'm printing the line, the case, then I'm printing I, and then the I repeats itself. The main thing to notice here is that I is not 0 again. The reason is that the code is going within the loop, and it is looping within the variable customer ID. So I can also write an if-else statement within a for loop. So suppose I want to select product that only fridge. So okay. So if so, let me try something else this time, something different. So I'll be looping within the index of new DF. So my case variable changes to the index. So the index of new data frame, which is 0 to 4, will be carried on 1 in 1, and then I can print um, new df variable age with in. So I am basically trying to print the value of hung value of product at each index, including 0, 1, 2, 3, and 4. So index is not defined. The for loop does not know anything called index. We have mentioned a variable called case to carry the value of index one bit at a time. So we have been able to print the product by the index. Now I want to check if the new data frame product is equal to fridge, and if that happens, then I can change the value of customer ID to customer ID plus 1 at the location of index. Sorry, and in case. So let's see what this code really gives me as the result. I'll be printing the data frame at the starting and the end. Okay, so okay, so there are some issues here. The issues are basically that I have to mention this particular bit as a variable. We can also bring in the functionality of this function here because that handy in such a scenario. Um, I would have passed the values of customer ID and the product at one go within the code. Yes. I'm sorry it took me a bit of time. I was just troubleshooting through it. Um, yeah, so we had the data frame initially with us. We had the index and the product and the state. And in this particular code, what we are first of all printing the case and the new product variable, the index of case. So this is what we had done before. And now what I'm doing here is that if the new data frame product in the index case fridge, that in such a scenario, please update the value of customer ID with customer ID plus one. So if it is fridge, so as you can see here, the customer ID was fridge. So in such a scenario, if this scenario exists, another time we are using the comparison operator here. We are using the same comparison operator. We are not using an equal to operator. It would not have worked. Um, if fridge exists, then in ID by 1. So customer ID was 3 in the zeroth index, it is 4 now. And customer ID was 1, was 4 in first index, it is 5 now because the product contains fridge. So that's how we can use the if statement. If statement can also be used individually to just uh, print yes or no, or print anything, or utilizing it in any scenario. We can also use another function called in. So if fridge exists in new diff print yes. So I hope this one makes sense. Um,
Yeah, it does. Yeah, it does.
yeah. Uh, if you have, please ask me any questions if you have. There are multiple cases of for loops and data frames, and we use it day in and day out. Um, as going forward, while we will be doing manual coding or live coding, or we'll be dealing with some case studies, you will get to understand more about the for loops um, and the if else statements in picture.
Yeah, I understood. It's more like what has been expected out. So if I know what has been expected out, then I can always put.
Right? It is yes. So it is basically selecting a variable, an element in a few. So, for example, if I create a list called for item and list, I'm creating a random number, suppose np dot array 50. So let me just print item in here. So it will and it will print the numbers that will come here. But if I am also utilizing if statement, so if item greater than 10 the item. So in that scenario, I am only printing the items that are greater than 10. So for basically loops within a single value at a time. So yeah, so you can do whole lot of things around a list. There are also ways to go to every second column, every second row in a data frame using list, which can be done using accessing an index, choosing every alternate value there. So there are a whole bunch of tricks and tips that you can do around for loops. And there's also another function called zip, which is very useful while dealing with a for loop. And it also gives you, so let me just place a list of something between So herein I will be providing two inputs for loop. One will be the list in the range of 2 to 20 separable by 3, and the another list of between 20 to 50 separable by 3. And both of this list, the first element will come together and the second element will come after the first element. So I can name it as first and sec. So let me just print first. So I'm printing them both together because these are two outputs that will come out of the for loop. So the first list is coming between 2 and 20. So this is the list between 2 and 20, 2, 4, 6, 8, 10, 12, so on. And the other one the is the list between 20 to 44. But the main thing to notice here is that these are coming both are coming one at a time. So I can access both of them at the in the same for loop. And so this is something that comes in very much handy when we want to access two columns in a data frame at the same time. And we can always do all kinds of functionalities within these. So if I want to do something like first, say the list called A. So let me give an example for that. I'm making an empty list, and then I am appending the value first per sec inside the empty list, and I will be printing. So as you can see here that in the first run I am printing the A is an empty list. A gets appended by the sum of first and second. So we get 20 plus 2, that is 22. In the second run, now A list value called 22. So this is the best example so far for loop. Yeah, the code goes into taking the second value from this range and this range, the second 23, and it adds up them to append to A. So the A is appended by the sum of 23 and 4, which is 27, and finally the list A looks like this. And the list A gets on getting updated and updated with the new values of the summation of first and sec. So that's how this thing works here. So if I'm not sure if this will work or not. So as you can see here, I've also put a condition of if, wherein I'm telling the computer if there's a 32 in the list, then print yes. So as you can notice here that it was 22, then 22 and 27, and finally when were added in the third index, then we got the value 32. And after it printed the value of A here, it went to the condition to check if 32 value is present in A. If yes, then please print yes. So the computer yes printed yes, and it will go on printing yes because 32 value is already is So that was a summary about the for loop and the if condition. Um, we can also use we can uh, we can further use if condition to incorporate elif and else. So we can functionality here. So if 32 is at A, then print A. If it is not, then print no. So it is starting printing no from the start for the first two bit because the 32 was not present in the first two bit, and then it started printing yes. Another condition between if and else is an else if condition, wherein if 32 is not present in A, then it will go to the else if condition and it will check 30 for suppose 37. So if 37 in A, then 30. Hello.
Yeah. I'm here. I'm here.
So, so this one is another very interesting example. Here you can see that 37 is already present in the fourth printing and hello. The reason for that is that else if statement works in such a way that only if the if condition is not fulfilled, then only it will go into else if condition or the else condition. Since the if condition was fulfilled in the first go, it was never required to go into the else if condition, so it never printed hello. If 37 was present for, then it would have started printing 30 yes from the fourth instance, but it might have started printing hello from the third instance. So something like this, wherein we have 32 here, but we do not have 37. So the computer went to this statement, says if it's 37 in A, no, there is not 37 in these three values. Yes, but the code gets updated next time, and 37 is also included into the code now. So since the first condition is already fulfilled, 37 is already present, it is printing in yes. Even if 32 is already present in the output, it will not even go to the second statement. So that's how the if else statement works, and that is the right way to logically also to save the computing power of the system. So yes, that is a summary about foreign if-else loops. We can always have more detailed discussion on this, and also about how to create prediction models on using Python. So we can also create models from scratch using like linear regression or decision trees or support vector machines from scratch in Python without without using the scikit-learn library, since we already have so much information about the arrays and the list and how to manipulate data. I suggest you guys to practice more on this subject by taking up any data frame and try to do some hands-on, or I can devise a practice uh, for the team, for the class of students. So yes, thank you very much for joining on data manipulation. We shall move the presentation on different trees and random forest if deemed necessary right now.
Well, that's going to work out, okay. And it's been a good amount of information that we actually gathered today. And I really want to thank you that you spent so much of time with us uh, with respect to showing us the different arrays, different NP, if or else loop, zip loop, so many loops. It's good to know about this, that a person from a non-technical background, if they do a bit of practice, they would be in a better position to understand the whole scenario of the data analytics part of it.
Right. Thank you very much.
Perfect. Well, I just want to say thank you to you, and it was immense pleasure having you on to this presentation.